In this video, we're gonna create a random walker algorithm to procedurally generated level in Godot 4.4. At the end, you will have something that looks like this, where you have like different walkers that work to carve levels inside Godot 4.4 within a boundary. This is an extract of the new update that I've made to my course, which is about creating a procedurally generated roguelite in Godot. The new update is 52 new video about how to create a procedurally generated roguelite from scratch, so it's very cool stuff. The previous course was made in Godot 4.2 and I remade it in Godot 4.4 using the new tilemap layer system. But I kept the two cores because the two cores are using different methods. So I'm still using the same algorithm, which is the walker, but I am using it in a different way. In the old course, I was creating a grid and I was carving inside it. In this new course, I'm starting from scratch, from nothing, and I directly create the level through the walker, and then I instance levels and enemies and lots of stuff inside the walkers. It's a completely brand new method that is actually fully controllable and that works, in my opinion, better. And I really personally appreciate it. I've spent a lot of time at the beginning of the year working on that. I will leave a discount in the description of this video for the course, and it will be valid up to the 4th of November 2025. And then I will try every month to put a discount for the course so it's accessible. I also have made a similar course for making a similar game, procedurally generated roguelite, in Unity 6.2, so I will also put the link in the description. But I will make a separate video about this because that's something that I've never really fully approached on my channel, but I am not using only Godot, I'm using a variety of tools, and Unity is one of them. For following that video, you don't need much. What you need is just to have like a 2 square globally, 2 square of 32 pixels each with a different color. That's going to be our tile set for that video. So if you want to learn procedural generation, but you are on the right video, and we're going to start now. Here, what we're going to do is we're going to create our scene. So I'm going to click here on 2D scene, and I'm going to rename that node. I'm going to call it projection, like this. So what I want to do here is I want to create 2 nodes. The first one going to be a tile map layer, this one right here, not the tile map here because this one is deprecated now, but like the tile map layer right there. We click on create. That tile map here, I'm going to click and I'm going to rename it ground. And then I'm going to create another node, which is going to be my camera 2D. And I'm going to leave it like this. So now we need to have a texture that we need to put in our ground, because our tile set here is what we're going to use for having our procedural generation working. So for that, we need here to create a tile set. With tile set, click on empty, new tile set. You click again, and then here you have the setup that you want. I'm going to change the tile size by 32 and 32 because this is important because my player going to be around 20 pixels in real, so it will make the background look bigger than him, which will be a very useful thing to have. And so now we need to have a texture. So for that, we need to go here into tile set, and we need to import an actual texture into our res folder. So for that, I already have open a folder. You will have it in the resource of this video. You go to procgen, tile set, and here I have the tile set that I'm going to use. So what I'm going to do for now is I'm just going to go here to my res folder. I'm going to right click on it, create new, create folder. And here, this one, I'm going to call it procgen. And then inside, by clicking on my procgen, I'm going to right click, create new folder, and I'm going to call it tile set, actually, tile set. And then inside my tile set, right here, I'm going to click another folder. It's going to be called sprite. So like this, everything is organized well. We know where everything is. And so now I just need to, for now, drag those 2 tiles right there. I will do the rest later on. You will already have everything. I'm building the course right now, so like I'm doing things little by little. And so here now we have our texture. So what we need to do is, like, with the ground selected, with the tile set that we have created, with the fact that the tile set is on 32 by 32, if you don't see that, it's just you need to click on the tile set and you're going to see that. So now what we need to do is here on the tile set, we need to take the tile set 2 and we drag it here. We click yes, and that's it. So now we have our tile set that is set up. And so with that done, now in the next video, we're going to be able to start to code the procedural generation of our game. So I will see you in the next lecture. So in this video, we're gonna start to create the worker. So for that, we need to go to our project node here, and we need to click on the plus icon right here to attach a script. That script gonna inherit the node 2D that we are attaching the script to. And here, for the path of the script, I'm gonna click here, and I'm gonna go to my project, and here I'm gonna create a new folder now inside that project folder right here. So for that, I'm going to click here on the plus, and I'm going to create a folder. It's called script, and here this one I'm going to call it worker, like this. So now I'm going to click on create, and I have my node that is created. Now here what we need to do is we need to create a bunch of variables that we're going to use for creating a worker. So the first thing that I want to do is I want to make sure that my worker is something that I can reuse and that I can tweak easily. So in Godot, normally when you create a variable, for example, here I'm going to create a variable that we're going to use that is called num workers. I'm going to set it to be an int, and that int I'm going to set it to be 3. If I want to modify now that value in my game, I need to hard code it, which means that I need to actually change the number in the code, which is not automatically something that I want. What I want is I want to be able to change things in the inspector right here, for example. I'm going to make a bit of space. So for that, here, just before the var, what I can do is I can just put @export, and now it export my variable right here. And most of the variable that we're going to create for the worker, they're going to be like export on average, because I want everything to be as tweakable as possible. So here I'm going to create a new variable. The variable, I'm going to call it max underscore iteration. This is going to be in charge of giving a limit to the worker, so the worker doesn't run eternally. So here the worker going to run 1,000 times, and then after that it's going to stop. Then after that, I'm going to create another export. That export variable, I'm going to call it custom underscore viewport underscore size. And here, what I'm going to do is like I'm going to assign it to be a vector2. And the vector2, I'm going to set a size to it. So that vector2 going to be of 920 by 1080. So like a classical full HD resolution. I've made a typo here. So now what we need to do is we need to continue. And so this time it's going to be another export that we're going to create. I'm going to call it step underscore size, and I'm going to set it to be an integer, and it's going to be by 32. So this is going to make sure that my step size are the exact same size that my 32 pixel. If your tile size here is 16, you need to make sure that your step size right here is 16, because this is going to make sure that the worker, when it goes somewhere, it moves of 32 pixels. That's globally the logic of this. So now with that done, but we need to continue again. So now what we're going to do is we're going to export a range. So here I'm going to do export underscore range. And what this does is allow me to export a range between two numbers. So here I'm going to show you, it's going to be a bit more easy to understand. So here I'm going to set a float, and so I'm going to set it to 0.0 and 1.0. And then here I'm going to call that var ground underscore chance. And I'm going to set it to be equal to a float, and it's going to be 1.0 per default. So here what we are doing is now with that export created, here I can, for example, slide my ground chance, not change. Chance, voila. So here I can export that. And so what this is going to be in charge of is making sure that when the worker passes on one tile, if it's on one, there's a 100% chance that you are having a tile that is put there. But if it's like, for example, let's say 0.4 like this and stuff, it's gonna give 4 chance out of 10 to put a tile there. That's basically what we are doing here. So this is something that we'll explain a little bit later on, but that's for creating like island and stuff like this if you are into that. So then I'm gonna create another var. It's gonna be a tile size, this one. And that tile size is going to be also an integer, and I'm going to set it to be equal to 32 by 242, like this. This again, like, is just to make sure that the tile size is the same than the 32 pixel right here. Then we need to continue. So here what we're going to do is we're going to create an export variable, and this one we're going to call it ground tile chord. Chord here means coordinate. And this one I'm going to set it to be equal to vector2i, which means vector2 integer. So it makes sure that the vector2 is always an integer, so not a decimal number. And so here I'm going to set it to be equal to vector2, and per default I'm going to vector2i, and per default I'm going to set it to 0 and 0. This is in charge of the tile coordinate for the ground in the tile set. And so we're going to continue again. We're going to make a lot of variable. I told you there was a lot of variable involved. So here, this one, we're going to call it borders. And here, we're going to set it to be an integer, and it's going to be 3. So this will be the, when we're going to launch the game, we're going to create a border that's going to contain the worker, so the worker can't go out of the border that we have set. And I'm putting it as an export so you can tweak it into the inspector. And globally what I'm doing here is like I'm going to take in code, I'm going to take the size of my tile set. So for example, my tile size here is 32 pixels, and I'm going to create 3 times 32 pixels as a border. So like this, I'm making sure that I can contain my worker. And last export that we need to create for now, which is step per frame, and here it's also going to be an integer, and I'm going to set it to be 10 per default. This is going to be the number of worker update per frame. This is going to animate globally our worker on screen so you can understand what I'm doing. Now that we have done that, we need to create some onReady var variable. So here we need to have like globally two variables assigned. Here we need to have our ground and our camera. So here what I can do is I can click on my ground, I can drag it here, and I can click Control, and then I can release, and it's gonna create the variable for me, as you can see right here. So this one I'm not gonna call it ground, I'm gonna call it ground layer. So just to make sure that like this is a bit more intelligible. And here, this one, I'm going to do the same. I'm going to drag it here, then click on Control and release. And I'm not going to name it Camera 2D. I'm going to rename it just Camera, like this. Now, we need, again, some variable. I know, there's a lot. Those variables, now we're going to go into the meat and potato of the thing. We need now to create our worker. So here, that worker, I'm going to call it workers. I'm going to set it to be an array. And that array gonna contain vector2. So this is gonna contain globally all the tile that our worker gonna work in. And that vector2 gonna be a vector2.i. So like this, by removing the decimal, we are making sure that we are removing a potential error. And so that array, I'm gonna set it to be equal to an empty array. So like this, we're gonna fill up every time that we are resetting the level. Now, we need to have an iteration count. So here I'm going to create iteration count, and this is going to be in charge of keeping track of the number of iteration that the worker is doing. Iteration here means that the number of work the worker is making. Then here, another variable is simulation running. This is for us. So like this, we can see if the simulation is running. The simulation here is the generation, so you can replace, for example, generation here, but simulation makes a bit more sense in my opinion. And then here, another variable going to be a viewport underscore size, and I'm going to set this one to be a vector2. So with all that done, now we are globally finished with like those variables, and we can start to code the logic of our worker. So the first thing I want to do is I want to make sure that I have the possibility to regenerate my worker pressing a key and quitting my worker pressing a key. So for that, I'm going to use a function that is built in Godot. It's called input, like this. And inside that function input, what I'm going to do is I'm going to say if event dot is action pressed, like this, and it's going to be UI accept, which is the space bar in Godot. Then here, what I want to do is I'm going to make a print for me. I'm going to say resetting simulation. And then for now, I'm going to leave it like this. I just need to make sure that I'm not making any typo. Voila. And if input, so here I'm typing input instead of event. is action just press, and this one here we're gonna look for UI cancel, which is the escape key. Then here what we want to do is I want to print, for example, quitting game, and then I just want to quit the game like this, get 3 dot quit like this. So now I can save, I do Control S, I save my stuff. I'm gonna go to my project folder, and here I'm gonna create a new folder. I'm gonna call it scene, and I'm gonna save my project folder right there. The first thing I want to do is I just want to test that everything is working. So here I'm gonna press on the play button. It's gonna ask me to select a scene for the first time. So here I'm gonna click select current. And so now I have my scene that is working. And if I press the escape key, it quit the game. So that's perfect. So now that all those variables are created and the logic is into place, I can start to create the logic of my code. So the first thing I want to do is here I'm gonna create a function. And that function I'm gonna call it reset underscore simulation. And that function gonna be in charge of globally resetting our simulation. So globally reset here is a bit misleading. Like we could also call it start, but we're gonna use it as well for resetting our simulation. So that's why I name it reset simulation. And so here what I want to do is I want to assign my ground layer that we have created right here. And I want to say dot clear like this. So this is going to make sure that when we are resetting or restarting our generation levels, we are clearing everything that has been already drawn on the tile map. Now that we have done that, what we need to do is we need to also get our worker. So remember our worker is where right here, and our worker is globally the array that we have with all the steps that has been visited. And here, same things, we need to say clear, like this. Can actually put it like this, that would be nice. So now I need to globally start to have my worker going somewhere. So here I'm gonna create a variable inside that function, and I'm gonna create grid size. And grid size, I'm gonna set it to vector2 I, and it's going to be equal to a vector2 I, and in between the parentheses I'm going to look for my viewport size, which is a variable that I've created right here, and then out of it I'm going to divide it by the tile size. So here what we are doing is basically we are getting the viewport of our screen. So basically we have a length and we have a height, and by dividing it by 2 we are creating through code those values. Now that we have done that, what we need to do is we need to also make sure that we can center our worker. So here I do var center vector2 I, and I make sure that I take my grid underscore size and I divide it by 2. And now what I can do is I can globally create a for loop. So for I in range, and here between parentheses I can take my num worker that I've created right here. So this is in charge of the number of workers that we're gonna make work on our level at the same time. So here we have set it up at 3, so we're gonna have 3 workers that are gonna be like working in the tile map at the same time. And so here what I can do is I can take my workers that I have created right here, remember, my array, and here I can say dot append, which is gonna add the number of work that my worker gonna make. I can take center, so like this I give it a vector2 I, so like I give it a position. And so here then I need to get my ground layer. So my ground layer is my tile map that is right here. And what I can do, I'm just gonna close all of this, voila. Here I can just set underscore cell, and I can take vector2 I, and then between parentheses I'm gonna take center.x and center.y, which is the vector2 that we have created right here, the variable. And then here I can set 0 and then ground tile codes, the variable that we have created right here, which is also a vector2.i. So now that we have done that, we can get out of the for loop. We can put our iteration count to be equal to 0, and then we can set, where is that? iterations. I think I've put a S. Iterations count. Voilà. So I'm going to remove the S. Iteration count 0. And is simulation running, we're going to set it to be true. So this is going to make sure that we can start our simulation. So now we have done that, we need to actually have a function to move the worker. So that's what we're going to do now. We're going to create that function. So I'm going to call it update underscore workers. And globally here, what I want to do is I want first to have a variable that's going to be called tile underscore placed. And it's going to be an integer. And I'm going to set it to be equal to 0 by default. This is going to make sure that we are tracking the tile that we are working on. Now we're going to create another for loop. So I'm going to say for I in range. And here what I want to do is I want to get my worker dot size. So here I want to get the worker dot size like this. And globally here what I'm doing is like I'm putting in a loop my worker size. So like this, I'm making sure that I keep track of everything. And here now we're gonna set the direction of our workers. For that, we need to create a new variable. We're gonna call direction, and I'm gonna set it to be equal to a vector2i like this. And a vector2i gonna be a list of vectors that we can go to. So here I'm gonna open square bracket, vector2i, and I'm gonna say dot up. Then I'm gonna put a comma. I'm gonna copy the vector2.i with the dot here. So like this, I don't have to type that all the time, like this. So here is going to be down, then I put a comma, I passed vector2.i, here is going to be left, put a comma, vector2i is going to be right, and I think I'm good. I just need to also get out of the list, and here I need to create another square bracket, rand I, which is a randomized integer. So here is going to be make sure that all those vector2 that we have here are going to be randomized, so they're going to be picked per default. And I'm gonna multiply it. I'm gonna put a percent sign, which basically gonna make sure that it can't go over those 4 rows that we have right here. So I do that for like this. And so here now we have the basic for globally having direction for our worker. So now we need to make sure that we have a variable. So here I'm going to call it new underscore pose. And that variable is going to be in charge of globally calculating a new position for our worker. So globally what we're going to do. So here I'm going to say vector2 I, and it's going to be equal to workers with square bracket and I, so this is the number of iteration, plus direction, multiplied by a little calculation that we're going to do, which is step underscore size divided by tile size. And now that we have done that, we need to make sure that the worker stay within the boundaries. So here I can put a comment, and I'm going to say ensure the workers stay within the grid boundaries. And so here what I can do is I can create var grid underscore size. I'm going to set it to be equal to vector2 high, to be equal to another vector2 I, like this, vector2 I, voila. Viewport underscore size, and here we need to divide it by the tile size, so like this we are creating our screen already, our screen, or we are creating globally a surface like this. Then after that, I'm gonna set another variable that's gonna be called minimum bound. So here I'm shortening it in min bound. Again, it's gonna be a vector2 I equal vector2 I. And here we're gonna this time take our border. So remember that we have created the variable border. Where is it? Right here. So here that's what we're gonna set. So I'm gonna say borders and borders. So this is gonna make sure it stay contain those borders that we have set up. And so now, but we just need to make the calculation. So if new underscore pose is greater or equal to min bound dot x, and new underscore pose dot x is smaller than max underscore bound dot x, and here for making it more readable, I'm just gonna put a space like this, and I'm gonna just put a little bit of an indent like this. So here, what I need to do now is I need to get my new pose, this time .y. And here I need to make sure that if the new pose.y is greater or equal like this to min bound, min bound dot y and new pose dot y is smaller than max bound dot y, then here what we can do is we can just get our workers, square bracket I, and here we're gonna just set it to be equal to our new underscore pose, like this. And this globally update worker position. That's what we are doing right now. So here, there's one thing that I forgot to put is my max bound. So here I have max bound, as you can see, but I don't have it right here. So here I just need to create another variable. I'm going to create max bound, like this. And it's going to be equal to a vector2i. And I'm going to, here that max bound, what I'm going to do is I'm going to set it to be our grid size. So the grid size that we have created. And that grid size going to be of minus the vector2, vector2i, border and border. So like this, we make sure that we have everything set up nicely. So here I just made a typo, which is right here. I just need to put the dot x, and so now we don't have that error anymore. So voila. So now we have the basic for walking or for making our walker. So we have one last thing that we need to create. So another function that I'm going to create just right here. And that function, I'm going to call it create underscore level. And that function create level. So here what we're going to say, if not is underscore simulation running, what I need to do is I need to return. So this, what it does is that it skip if the simulation is complete. I'm putting it for, I'm putting a comment so like this, it's more, it makes more sense. So now I'm going to make again another for loop. So for I in range, and here we're going to take our step per frame right here. So I can just copy it. So here I can just put that step per frame. And so here what I'm going to do is I'm going to perform a multiple step per frame for the faster generation. So here I'm going to say perform multiple step for the generation. So here I'm going to take my iteration count. So if iteration count like this, and I'm going to make sure that if the iteration count is greater or equal to my max iteration, like this, then I need to break. So this is gonna make sure that it stops once we have arrived to the maximum iteration we were authorized to, which for us is 1,000. So here I'm just gonna say, I'm gonna put a comment, stop if the maximum iterations are reached. And if it's not the case, what I'm going to do is I'm going to call my update worker, which is right here. So I'm going to call my update worker. And then I'm going to say iteration count plus equal 1. So here, for clarity, I'm going to say up like this. I'm going to say that it moved the move worker, and it plays style globally. That's what this does. And then after that, what I'm going to do is like here, I'm going to make another if statement outside of the loop. If iteration count is greater or equal to max iteration like this, then here we can do something which is simulation running, and here we can set it to be equal to false. And now we are good to go. And with all that done, normally this should work. So the thing that I need to do is I just need to create normally my process function. So here I'm gonna come here, I'm gonna create function underscore process. And here I'm gonna call my create level function like this. And with that, almost everything works. I think it's not gonna work if I launch it right now. Let's see. Yeah, it doesn't work because there's one element that is missing, which is the setting of our camera. The setting of our camera, we're gonna make it into our function ready function. So I'm gonna create it on top of the input. So func ready. And here what I need to do is I need to get my viewport size, and I need to set it to be equal to my custom viewport size. Then if there is a camera in our scene, which is the case, if camera, what we can do is we can either, we have two methods that we can use. Either we are setting up the camera with a fixed zoom and top left encore, that would be all right, but I'm gonna make method 2 because it's a better method. I'm gonna create a var grid underscore size, and I'm gonna set that vector grid size to be a vector2i, and it's gonna be of type vector2i, and then I'm gonna get my viewport size, and I'm going to divide it by the tile size, as you know it by now. You have made it. You have made that several times in this video. Then I'm going to get my camera position, and I'm going to set it to be equal to vector2 grid underscore size multiplied by the tile size, which are the two variables that we have created right here. And where is it? The other one we have created somewhere. So that's right here. Voila, so tile size, and here we're going to divide it by 2, and then here just for this video I'm going to set the camera zoom to be equal to a vector2, and here I need to make some tests, so I have different resolution screens. So here I'm going to see this one 07 and 07. I think it's going to be a bit different, but like let's see. So now I'm going to launch. Yeah, it's not automatically working the way I want. So here it's not going to work because there's one thing that is missing. I'm going to show you, which is in my update worker. So now that I've made all that setup, what I need to do is I need to make sure that I can assign the ground chance that we have created. So here in my update worker function, what I need to do is I need to come, I think here, and I need to check if randf, so random float, is smaller than ground underscore chance, ground chance. Then here what I need to do is I need to place globally here what I'm going to do is like I'm going to make a comment, place a ground tile based on probability. That's what we are doing here. So here what I need to do is I need to get my ground layer dot set underscore cell new pose 0 and ground tile coordinate. So here what I'm doing is I'm just making sure that I'm respecting the method that there is in the tile map layer set cell. You can see the coordinate vector2i, source ID is integer, and atlas coordinate and those kind of things. So here the 0 here make a reference to my ground tile set, which is right here. And if I hover my ground tile set, if I come here, you can see source 0. That's what that 0 here is making a reference to. And so now that I have done that, what I need to do is I need to first I need to make the indentation work this way because I've indented badly. Voila. And so now I just need to make sure that tile placed is updated. So here I'm going to say tile placed plus equal to 1. With all that setting done, normally now this should work, and it doesn't. And so here this is not working because I've just forgot one thing, which is my function ready. In my function ready, I just need to call my reset simulation function. So here I'm just going to make a comment, start the simulation. And here what I need to do is I just need to call reset simulation. And so with that done, now this should work. So let's have a look. Voila, it works. Finally, so that's perfect. So now what we need to do is we need to make sure that we can control the viewport and stuff. So here, for example, I'm going to go to project setting. And if I go to window, you can see that my viewport is set on 1152 and 648, which is like smaller than my custom viewport size. So here I can put 1152, 648. And if I launch back the game now, you're going to see that now it is contained within the screen size that I have created right here. And now here's the magic, is that we can, for example, change the number of walkers we want. So here I can put 1, and it's going to create my level like this. Here we can change the state per frame. And for example, I can come here, 5, and I can change a bit the speed of my my frame of my walker. So for example, if I put 2, it's going to be a bit slower. You can see that now it is slower and stuff, and so that's good. I can change the number of iterations. For example, I can put 500 instead of like 1,000, and it's gonna iterate less. It's gonna stop at some point very quickly. You can see it's gonna stop soon, voila. And so on and so on. So here, what I can do is I can just put it back at 920 and 1080. What I can do is I can go to my project setting. I can change that. For example, I can put 920 and 1080. 1080 like this, and then if I launch back the game, it's gonna put it in full screen almost, and now you can see that we have way more space to work with, and so that works very well. And if I press the space key, it doesn't work. Why is that? So here it doesn't work just because here in my input event, I just need also to call my reset simulation. So I need to come here, voila. So now if I launch back the simulation, it launches and stuff, it makes its thing, and if I press the space bar, you can see that now it continues. So that's perfect. So now we have the worker that has been created, and we have the base right here for our game, and we can like set up the amount of worker that we want. So for example, here I can put like 2 workers, and then you can see that I have 2 workers that are moving at the same time on the screen. I can put like, let's say 6, for example, and we're gonna have 6 workers that are gonna move in different directions, and that's gonna populate our level. Still, we're staying within boundary. You can see that it never go out of the boundary of our screen because this is because of the border that we have created. And so all of this is set up now, so that's perfect. So now globally in the next lecture, what we're going to do is we're going to open, so we're going to have a worker, and when we have stopped creating the ground, we're going to create the background tile around it, still respecting our size and those kind of things. So that's what we will do in the next lecture. So I will see you in the next lecture. So now that we have done all of this, first what I'm going to do is I'm going to just put the actual size of my Godot project, which is right here. I'm gonna show you. So for my viewport is 1152 and 648. So here that's what I'm gonna do. So this will make sure that the worker is globally working in the right area, as you can see. So right now, like we have like a better thing. I'm gonna also lower my worker. I'm gonna put 2 workers, and I'm gonna put an iteration of like maybe 300. Let's see. Yeah, so this works better. So now what I want to do is I want to create the walls. So for that we need to have another tile map that's going to be in charge of placing the walls. So here what we can do is we can take for example this one, and we can copy it if we want. Just for the sake of showing you how to do, I'm going to recreate a new one. So I'm going to click on the plus, tile map layer right here. This tile map layer, I'm going to rename it background like that. I'm just gonna place it above the camera here. I think I'm gonna rename it background with a capital B actually. It's gonna be better. Voila, like this. And so tile set, I'm gonna click on empty, new tile set. I'm gonna click on it. I'm gonna restart, change the tile size 32 by 32. Here I'm gonna add a physics layer because we're gonna need to collide with it. So I'm gonna click on add element, and it's gonna add automatically the physics layer to it. After that, we're gonna be able to add it on our tile set. So now with the tile set selected, here I need to go here at the bottom tile set. I'm gonna get my tile set 1 here. I'm gonna place it here. I'm gonna say yes. So now I have my tile here. You can see that my texture region is 32 pixel by 32 pixel, which is exactly what we have at tile size, which is good. And so if I go to paint, I go to select the property editor, I go to physics layer, and here I have that shape that I don't need to modify because it's like the shape of my tile. I just make a left click, and that's good. So now we have set up the basic collision for our background. So now that this is done, what we need to do is I need actually to go back to my tile set. So tile set, I'm going to close it. I need to go back to my script, and here I need to add a reference to my background. So basically, like the same way that we have done here. So here, what I'm going to do is I'm going to say onReady var. I'm going to call it, I think, background layer. It's going to be good. Let's keep the same type of naming convention that I've put here. Is going to be of type tile map layer like this. The capital T, M, and L matters here, so you need to respect that. So I'm going to put here background like that. So now I have a reference to my actual background right here. And so now what we need to do is we need to also have our tile coordinate for the background. So here I'm gonna put it right here. I'm gonna make some space to make a bit of visibility. So here I'm gonna say at export var. Here is gonna be background tile chords, and here I'm gonna set it to be a vector 2i, and here is gonna be of vector 2 I 0 and 0, something like this. Voila. And so here is like you can put a comment if you want here at the end of it. This is tile coordinate for the background in the tile set. That's just exactly what it is. So now what we need to do is we need to create a function that's going to be in charge of placing the wall in the background. So here that function, I'm going to put it here and I'm going to call it func. So fill underscore background like this, and it's going to be of type void like that. And so what we want to do here is that first we want to get the grid size. So the grid size is globally the same thing that we have created right here. That's the same logic. So here what we want to do is we want to get that, so var grid size. And we want to set it to be a vector 2i. And we're going to set it to be equal to a vector 2i. And here between parentheses, we're going to put viewport underscore size. And we're gonna like this, and we're gonna divide it by the tile size, which is right here. So now we need to have a new variable that's gonna be in charge of checking the tile that are placed. So here I'm gonna call var placed underscore tile like this. It's gonna be of type int. We don't want it to be a decimal number. So here I'm gonna put it at 0, and then we're gonna make a for loop. So for x in range, and here we're gonna take our grid size dot x like this. Then what we want to do here is we want to make a nested for loop. So here we're gonna nest for y in range, and here is gonna be grid size dot y like this. So then here what we want to do is we want to get the cell position of our cell in the tile map, and then we want to make sure that we check if the cell is empty, and if there is a cell that is not empty, we are like there is a cell that is empty, we are placing our background tile. So that's what we are doing. So what we're going to do here is we're going to create another variable that's going to be called cell underscore pose, and here I'm going to set it to be of type vector 2i again, vector 2i, and I'm gonna set those vector 2i to be for our nested for loop. So it's gonna be a vector 2 vector it's gonna be that vector 2i x and y. Voila, that's where I was making the mistake, x and y. Voila. And so now what we need to do is we need to check if ground layer, which is like our ground tile map right here. If ground layer dot get underscore cell underscore source ID, here we need to get the cell position, cell pose. So this, what it does is like it goes to, I'm going to show you actually, but no, I can't show you because I'm making the code. But globally, when our worker is walking around, as you have seen, like we have the orange tile that are placing itself, and there is tile that are empty. And so what it does is like this part of the code is checking what are the tile that are empty in the ground tile map, and then by identifying them, we're going to be able to place the tile of our background. That's globally what we are doing here. So for that, we check that, and so we're gonna say get cell source ID, okay, that is double equal to -1. So here you can make a little comment, check if the cell is empty. That's why I'm putting the -1 here. And so if it's the case, what we need to do is we need to call our background. So background layer dot set underscore cell, and between send cell here, what we need to get is our cell pose, then 0, which remember if we go back to our tile set, 0 here, I just need to go back to setup. 0 here is the source, so source 0. If you were having like another tile set right here or another tile set right here, you will have 0, 1, and 2. So here we have 0, so that's why we are doing that. And so with that done, after that, we also need to get our background tile coordinate, like this one. And then what we can do is we can place tile. So here I can come here and I can get the variable place tile that I've created right here, placed tiles, and I can set it to plus equal 1. And so what we can do as well is we can get out of the loop, and we can check. We can make some check. So here, for example, I can say just for a comment, print the number of background tiles placed for debugging, something like this. And here we're gonna print. Alors we're gonna open quote like this: background tile placed. I'm gonna make that. I'm gonna get out of this, and I'm gonna get my placed tile like this. And just also for clarity for yourself, because this is a bit of a complex code, so you can also here at background layer set cell, you can just make a little comment saying place background tiles. So with that done, now globally we have the logic of our script. So we need to update our worker. So globally, like now we need to call our fill background tile somewhere. And where we need to call our fill background is when we are creating the level. So we need to go back to our create level. And globally, what we need to do is like in create level, if our iteration count is greater than max iteration, so here, we need to call our background. So here, what we can do is like we can come here and we can say fill background, for example. So let's have a look. Is it going to work? I'm going to launch the game. Voila, it works. That's perfect. So now we have the possibility to fill our background, but the problem is like when we are regenerating, you can see that it stays a bit like this. So we need also to clear our algorithm when the worker is restarting. So for doing so, what we need to do is we need to go to our where is it? Reset simulation, and here we have ground layer clear, but we just need to do the same for background layer. We come here, background layer dot clear, and so now we're not going to have that issue anymore. So now if I launch the game, voila, and now you can see it reset perfectly. So we have the basic, and if I go here to editor and I go to not editor to debug visible collision shape, voila, if I come here, you can see that now we're going to have everything in blue because that's the collision shape that is working. So now if we are instancing a player, the player is not going to be able to get out of the map. And we're going to instance a player soon. For now, I just want to also do some other things. What I want to do is I want to, instead of having that boring tile right here, I would like to have the possibility to create a terrain that's going to generate automatically our background. So like this, we're going to have something that looks nicer and more like pleasant to look at. So that's what we're going to do. I don't know if it's going to be in the next video. I think it's going to be in one of the two next video, but that's what we're going to do soon. And that's going to be something that's going to really improve our game a lot. But already here, you have something that is working well. You have now in like some video, you have created like a walker that go around that you can set up nicely. And now you have like the background that goes around with like collision layer and stuff. So like, that's a good thing. So like, I will see you in the next lecture. So that's it for me. I hope this video has been helpful for you. If it's the case, don't hesitate to give a thumbs up and subscribe. And me, I want to thank you for watching. I want to thank you if you are considering buying the course. And I will see you in the next video. Bye!